did you hit your head? And I was like, no, let me explain what I mean by regular. I know, I'm going to pick on Colin because I was already picking on you. I know Colin, and when he comes to me, I know what work he's going to need to work on. Like, I know his math strengths and his weaknesses. Like, we have a rapport with each other. Like, the students know us and we know you guys. And, like, I like that a lot. And normally we would be here in, like, October. We would have, like, gotten over that hump a long time ago. But this year's obviously what it is. So finally I feel like we're leveling out. But with that comes us upping our expectations of you. What should I do? Drink coffee. Anyone not have this? Raise your hand. I'll bring you one right now. It was in your math notebook. If you have it, get it out. If you have it, get it out. You have it right there. I can tell you about how to All right. So, continuing with announcements. Khan Academy was due yesterday. Is it done? I'm going to update Khan more quickly than I used to, right? So, like, Khan Academy would be due on, like, Friday, and I would maybe update it, like, the following Wednesday. Like, that's going to start to be pretty quick. So, when things are due, like, the next day, math will get updated. We'll talk about your math notebook here in a second. The linear equations unit test. If you didn't submit it, it's missing. So if you have a missing on math, it's because you didn't submit your test. If you submitted it and you got a progressing, there's a progressing to mastery on Schoology. So on Schoology. Now, if you submitted it late, like one of you actually in here already did this, it was perfect. You emailed me and said like, hey, I submitted my test now and here's the grade I got. And that was perfect because I didn't even have to go look for the grade. Yeah, the unit test was on common. Now, but the progressing to mastery is on Schoology. Oh, I probably mixed up my words. You're right. I probably mixed up my words. So, if the math notebook is missing, though, you really just got to come show it to me. We'll talk in a second about how I lowered my expectations for this time, and they will be back up where they should be next time, but pretty much if you turn it in, you got to check. Khan Academy kickoff. I decided it is not fair for us to compete against Math 7 kids because, quite frankly, Math 8 would always win because we do more deep-level content, and it normally takes you a bit more time to do your homework.
Wait, so hold on. You're giving us more work?
No. But I'm not going to just let you guys win every week just by doing what you're supposed to do. So, it's Math 8 versus Math 8, and we will be doing blue versus green. So... for last week, because Math 8 won, I will be polling prize winners from the top 50% of performers in Math 8, blue or green, this Friday. So this Friday when we do Con Kickoff. Now, if you're not here on Friday, you'll get your prize the next day you're here. Like, I'll just make a little list. But so I will still pull Math 8 prize winners. But then, like, the next competition we do is blue versus green. It's not you guys versus Math 7. That was not fair. I do not know what you were about to say. If I did, that would have been telekinesis. I don't care. Ask questions.
What is it based on?
What is what based on? Dude, we went over this last week. If you missed class, you missed information, watch the video, catch up. Yeah.
I was going to ask, if we had missing work from the previous week, would that count towards minutes for
Yeah. Minutes performed in the week. I mean, yes, you could. However, you would get a missing in math first.
I'm not gonna do what.
So if you missed class last week, near the end of the week, and you have no idea what I'm talking about with con kickoff, go watch the class video from the class that you missed. That's why you don't know what's going on. I'm not going to repeat that and waste everybody else's time because we've all heard it, right? Like, I'm not crazy, right? I showed you guys con kickoff, and Tony Hawk made a video for us, and I see your Woodward sweatshirt. Yeah, you're wearing a Woodward sweatshirt, and Tony Hawk is one of the inspirational videos for con kickoff. Also, the dude who I can't pronounce his name, but the host of American Ninja Warrior, on there telling you guys to be Khan Academy Ninja Warriors. Remember him? Yes. All right, let's talk about your notes. So get out this. You guys should know what a rubric is by now, but this is not a complete rubric, right? Because the rubric should tell you what is expected. This is what I'm going to use to grade, right? So this is what you're going to get on your math notebook checks here and into the future. So what we're doing now, and I'm afraid that people flopping papers aren't listening now, is we are taking a fresh start, like a reboot, right? Like an unplug the power cord and plug it back in. So nothing from before today will matter moving forward on the notebook checks. So what do I mean by that is when I check your notebook in 2 weeks on the 10th, right, because you guys are blue, I will only be checking these couple weeks. So the first thing you need to put on the paper that you are writing on today is notes check on February 10th, only new. Only new stuff. So what you do today, moving forward. So guys, right now, if you are not writing on a clean piece of graph paper on the front of it where you should be writing, stop writing. I'm going to check these notes that you're writing in 2 weeks. And, like, don't set yourself up for failure. Yeah, right here, man, stack of it. More graph paper than I know what to do with. So your organization is up to you. Whatever you want to do to keep things clean and nice and neat and tidy, but I'm going to give you very specific directions for how to get checks on all 4 of these spots. So, here is the expectation of the rubric. Meaning, like, how do you get a check? To get a check for spot 1, every class period should have a header and a date. So that's the date out here. Every class period. Meaning, as I look through your notes, it should essentially jump 2 days at a time, right? Because we have class every other day. Now, you might have some Khan Academy work in there. That's fine. That might be daily. But your notes should have a header and a date every day. Dewan, why are you not writing? 27. So, thank you for asking that question. Make some sort of note in your notes. I have a Post-it here saying, like, hey, this is the start of my new stuff. Fold, like, dog-ear your paper or, like, grab a Post-it later. Like, we're going to do something so that when you turn in your next notebook to me, I'm going to know where to start. The second objective or rubric thing or whatever is that vocab is obvious and well-defined. What do I mean by that? Well, it's obvious. It's underlined or highlighted or has stars next to it. Juan, if you're writing these things down. Yeah, you're writing down what's expected of you. Like, we are. We're taking notes on what's expected of you. So this is number 1, right? Dates and headers. And how do you get a check in number 1? Every class period should have a header and a date. So to get a check for this spot, that's what you need to do. To get a check for the vocabulary and definition spot, your vocab word should be obvious, underlined, highlighted, put a box around it, put a star next to it. Important words should be obvious. And they need a definition. Writing scientific notation is pointless if you don't have a definition for what the heck is it. Writing exponents is great, but if you don't write in there how it's different than scientific notation, you end up on a mastery answering that question wrong. This happened to some of us because we didn't take good notes about it. For number 3, problems worked out / solved, to get a check there, essentially, if it was in class, it's in your notes. That you could write this easier and just say in class is in notes. If we wrote it down in class, if we did it in class, unless I say like, hey, don't write this, which I do sometimes, right? I say like, hey, don't worry about writing this. But if we write it down in class, if it's in my notes, it should be in your notes. And that's where your job comes into play a bit more of, I hope you guys are comfortable in like speaking up and saying, hey, give me another minute. Like, hey, wait, like I'm not done yet. Hey, don't move on. Hey, can you go back a slide? Like you got to tell us when we move too fast. Logan? So this paper will be totally separate from the math notes we take today. So literally this sheet is just your guide to like mastering your notes. So the header, quote unquote, I guess was notes check on February 10th. But this is not our lesson, right? This is not our lesson. These aren't really even math notes. These are just notes about how to take notes. And number 4, I will be honest, it was a Math 8 student who made me make this a category, who turned in a notebook that was their everything notebook. It had connections in it. It had science in it. It was a ruled notebook, like a lined notebook, not a graph paper notebook. None of that was what I said to do, right? I said have a dedicated math notebook of graph paper that is no other class. And this person's notebook, when I handed it back to them, I told them, hey, this is a train wreck. Fix it. So, graph paper, right? Like, so somebody earlier said, well, what's a train wreck? I said, well, first off, when I say graph paper, like all the time, if you're using lined paper, guys, we're old enough now, I think I can say things like this without you overreacting. It's like me saying, get out graph paper, and you like flip me off, and you're like, nope. It's like the easiest thing to do, right? Get out graph paper, and you're like, nope, I'm going to use line paper. That's like what you're doing. So stop it. Like, make your life easy. I'm telling you right now, if you turn in lined paper for math class, I'm going to tell you this should have been graph paper. Try again. Does that make sense? Like, guys, when teachers give you specific directions and you ignore them, it's like you're just telling us to, like, nah, I don't need you. I don't need your directions. And I don't care if you need our directions. They are what they are, and you're in school, right? Like, it's like when my boss tells me to do something a specific way. I might disagree, but I can't just flip him the bird and tell him to go away. I have to do it.
No, my boss!
It would be very interesting to try that with Mr. Flynn and see what would happen.
I'm suddenly curious. No, you'd probably get in trouble.
I would 100% get in trouble. That's life. All right, any questions? Your next notebook check is on February 10th, which I think might be a Wednesday for you guys because that's another funky week. My goal is to plan something that day that I could check your notebooks during class and give them right back to you. Or like I can have, whoa, that was aggressive. Or I get you guys to bring them to me like between Creative Start reading, whatever, and then I can do them through the day and get them back to you at class. That would be sweet, actually, if I could make that happen. Any other questions before we move on? / does anyone need more time to get any of this written down? Yeah, if you want. So if you want to tape this or glue this or staple it into your notes, you can. I don't need you to keep this little slip. I'll give you another one for the next check, because notice that this says January. Thank you. Final. All together. Cumulative means together. Cumulative is like, so your grade for Math 7 is a cumulative. Like, you did Math 7 last year. You got a grade for the whole class, but there were a bunch of other little grades in there. So cumulative means all together. So what you want is a check or a check plus here for cumulative, right? So if one of these things is a check minus, that might be okay, and you might still get away with a check on the whole thing. But if like 3 of these things are check minuses, yeah, you're not going to get there. Yeah, you're going to have to come, like, show me your notes every day then. So what's going to start to happen if you have a check minus moving forward, like after the next notebook check and after I spend so much time during class saying, make sure this looks exactly like this, what will then happen is your life will get a lot more annoying, and I just hope you'll change your behavior. Yeah, right? Exactly. It'll be like every time we write something down, like let's say Dewan decides to, take the route of like, forget you. It would then turn into like, we write down a problem, I'd be like, hey, Dewan, you got that written down? We write down another problem, hey, Dewan, you got that written down? Like, it would be annoying for him. And I'm only picking on Dewan because he and I have a pretty good relationship at this point. But that's not going to happen because Dewan's going to follow the rubric we just wrote down and make sure that he has high quality notes. Also, this, through semester 1, ended up filled with this. These are your notes for all of the fall semester. If you wanted to go back and see any class that we did, any notes that we took, they're here. Literally. So, hey guys, I'm going to start to keep track of how often you start talking when it's unnecessary, and it's going to blow you away. You're going to be like, I can't believe we did that 25 times in the span of 45 minutes. Stop. It just like throws me off, like when you throw in your 2 cents. Now, if you have something to contribute, actually, raise your hand. Like, contribute. But if you're just like saying things off the cuff. So, the point I was trying to make before I got distracted was if you miss notes for any reason, you're absent and you don't watch the video, or you go to the bathroom for 20 minutes because you said you went to the bathroom, but really you wandered to school, whatever, they're here. So there's no excuse for you not having notes. So when like you whine and complain about having a check minus or whatever 2 weeks from now, I'm going to point to this and say, this has been here the whole time. Once we do stuff in class, I rip it out of here because I don't know why I don't just use loose leaf paper, but I like having a notebook better. I rip it out of here and I put it in there. So if you come to use this, it would be, you're not math 7, right? You guys are math 8. So back here behind the blue divider, your notes start here, and there's not very many because it's just been like the past week or 2. It will. Now, funny enough, math 7 was the biggest stack of notes from fall semester. This was their stack. Go on.
Do people do that? Like, just walk around the school and they say they're going to the bathroom?
Pre-COVID, yeah, probably, and sometimes we would just tell them to. Like, hey, go take a lap. Like, you can't focus right now. Like, just leave. Yeah, but now it's a bit trickier.
Yeah, he just took me out and said go to the bathroom.
All right, so this is where we ended last time. So our header today, right, we need to make sure we all have the same header, is going to be solving systems, but then put a semicolon. Mainly today, we're doing graphically, or I guess we can just say, yeah, I think graphically is the right word. Graphically and algebraically. Solving systems, graphically and algebraically. Underline that. Now, this should be on a brand new sheet of paper. Sorry if you started writing that, but notice that brand new sheet of paper. I mean, I advise that people don't use the back of graph paper because it gets really messy and it's hard to keep track of. So, if you really did not use much space for the rubric notes we just took, I guess you can continue on, but normally you want to start class with a fresh sheet or like a very obvious transition. And today's date, right, we got 27. Right, top right is the most convenient place to keep it out of the way. I also in college got in a habit of I would put my date out here. I would just put it in the column where the hole punches are because it felt like wasted space. And then if I like used the same page for another day, I'd just write like 128, right? I'd write like the next day. Yeah, if it was under, or just do a new header, like in the middle of the page. Headers don't have to be at the top necessarily. So solving systems graphically and algebraically. So who can remember how we were dealing with this where they give us negative 5x plus 4y equals 3, and then x equals 2y minus 15. This was not graphically or algebraically. Zoe? Not actually. We can. Yeah, this was through our method of substitution, right? Where I believe we solved this problem. I forget if it was your class or the other class, like blue or green. But we plug in the x, and then we solve for the y, plug the y back into the other equation, and we solve it from there. So, let's practice this at least one more time. So let's solve this top one together. No, we did that last time. So this is what we're writing down. Notice I didn't write any of that down, right? Of what we just spoke about, I didn't write any of that down. Now I am writing this down. 2x plus 7y equals 3. So how we're going to deal with this? Replace, because the x is isolated right here, we're going to replace the x in the starting equation, the first equation, I guess we can call it, with the value that we have for x. So instead of saying 2x, we can say 2 times negative 4y plus the 7y equals 3. Go ahead and finish this out on your own. I'm going to pull this out of where you can see for a moment. Now getting your y is only halfway there. Once we get our y, we have to plug it back in to solve for our x. So right now you should be checking, like in your brain, right, do I remember how to do this, or should I ask a question? Because I'm about to move past this, like when we move on to the new stuff for today. So you need to speak up if you want extra review for solving the y. When we plugged in the negative 4y to replace the x, when we substituted, we got negative 8y plus 7y equal to 3, which gave us a negative 1y is equal to 3. And if the opposite of y is 3, then the actual y is the opposite of 3. Right? So if negative y is positive 3, then positive y is negative 3. What we actually did was multiply both sides by negative 1 if you want to be technical. Or we divided by negative 1 if you want to be technical. Yep. But I'm not done. Because now I need to take my y over to my x to solve for what x is. So now we say x is negative 4 times the thing I just found, negative 3. And we get that x is 12, making the solution 12, negative 3, because we have to be careful that we write that in x, comma, y order. Any questions on the substitution method? Guys, it is your job as a Phoenix student to tell us when we don't do our job well enough. You got to tell us when stuff doesn't make sense. So we're all good with this. This is one of the older assignments. I mean, I think they all had the same due date, but it's one of the older. So we can come back and do more of that if we need to. But for now, I want to make sure that you guys understand how this works. And I have a little, secret, not secret, But I think there's something you guys haven't realized about how you can solve these a lot easier. I bet the first thing that you're doing when you approach these problems that tell you to use the graph, and don't, like, this is not a tell me I'm wrong, because I hope I'm wrong. But I bet a lot of you are just setting this up into the y equals form and the y equals form, graphing both of them, and then going from there, which works. But there's another way we can deal with this. Yeah, if you want to contribute, raise your hand and give me your idea, Sevi. You're not wrong. You're absolutely not wrong. But what's the y-intercept and the slope here? It's not in nice form. And this isn't in nice form either. So we would still have to manipulate. I agree with you. What you're saying is right, but I would still have to do a bunch of work first. I'm trying to avoid work. I want to be lazy here. Or, I mean, I want to be efficient here. Idea? And I couldn't tell if you had a hand up too, or if you were just telling Colin to be quiet or what. We can. We could. We can / we could. I'm just arguing we shouldn't, because I want to be a little bit more efficient. Okay, considering you said it doesn't work all the time and now you're using words like basically, we're just going to seal that one up right away. If I want to find a couple points, guys, plug in a value is another option always. So if I plug in an x of 1, what would y need to be for this to be true? That may be a little bit tricky. So what if I plug in an x of 0? Well, when x is 0, what would y have to be to make this true? 1. That tells me a point. If x is 0, y is 1. Now I just need to find another point. So if x is, I don't know, -2 or -1 or I can just plug in any number I want. So I would go even, right? Because this is an even number, this is an even number. So if x is -2, this would need to be 4. Yeah, if x is -2, this value would need to be 4, so y would be 2. So actually, that, right? If I make my x -2, and guys, I'm just showing you another technique that can work. If this doesn't make sense in your head, don't do it, right? I'm not saying you have to, but this, depending on the form that they're in, depends on when this is easy versus when it's more difficult. So now if I plug in an x of 1, this gets me 2. And guys, I should make this bigger, because especially if you have any vision issues, this is probably a bit tricky. If I plug in an x of 1, what does this need to be? Well, it would need to be -10. And that gets a little annoying. So we can always go back to, if you put it in graphing form, like y equals, we can get it that way. Now, the other kind of easier option is just isolate one of the variables. Why this is so tricky is the x and the y are both on the same side. So if I just wanted to get rid of the 2y here, we could make this x equals 2 minus 2y. If you plug in a y, you figure out your x. Right? So another way here, I'm just giving you guys a bunch of options, so I want you to have like multiple ways to solve things. Another way is if you don't want to force it to get to 1y, x would be equal to 2 minus 2y here. Because if I subtract 2y from both sides. And guys, you actually don't necessarily have to write this. I'm just trying to make sure that you understand the thought process I'm explaining. So if I make y a number, any number, I will figure out what x is. So I can make y anything I want it to be. Sure, but that won't fit on our graph. So make it easy. You have so 0 would be a nice, easy choice. When y is 0, x is 2. So, okay, so I know 2, 0 is a point. When y is, I don't know, 1. When y is 1, x is 0. Right? When y is 1, if I think about this math, there's 2 points I can use.
And those are actually the intercepts, aren't
They are. Now we'd have to make sure that I actually did my math right. Yep, 2, 0. So these are actually, I just moved what points I'm using. So we do that same thing up here. Because the x looks a little bit easier to isolate. Or if we take the route that you guys take, which is fine. Sorry, I shouldn't say it with that like tone. I can immediately get 4y is equal to -8 minus 2x by subtracting 2x from both sides. I skipped a step there. Y would be equal to, I'm going to flip these around to make my life easier. So, -2 over 4x, -8 over 4. So if we get them into the graphing form, there is a nice, easy way that we can kind of memorize how many solutions we're going to have. Yes, but I mean, so you can either write it as minus or right, because this negative went here, and is here. Does that make sense? So, we said earlier, like lessons ago, did I really skip all the way? Oh, I remember why I did this. So, algebraically and graphically are actually very, very close to each other. So, the trick that we wrote down, I need a new sheet of paper for this because what we have to write down is probably at least 3 lines worth. In this first situation here, we're asked to solve it algebraically. Let's go ahead and write these down. Y equals -2x minus 4. They have to be with each other. I would write them first on top of each other, not next to each other. I know you're thinking equal values method. We'll start with the first one. We're going to write both down, but I would write the first one down and leave yourself space for now. So I get what you're asking, Logan. Can we write this equals and put my 3x plus 3 up here? We could, but I what we're going to look at here is just writing down some what do we notice? So I forget who said look at their slope and look at their y-intercept. Is that Sevi? Yeah. So when we look at their slope, are they different or same? Different, right? Different slope. When we look at their y-intercept, are they different or same? Different. So different and different. Now, I know we're supposed to solve this algebraically, but I mean, I'm just really in love with Desmos. So,
Yeah, I like you just type it in. Yeah, exactly. Wait, I think it's cheating. You just type it out the word. I thought it was cheating at first. Wait, you can do that?
so these, hey, stop. Here's the thing. You're not trying to find the solution here. When Khan Academy asks you this question, you're just trying to answer how many solutions could there be. I'm telling you right now, you will waste your time if you go to Desmos. It's awesome. It's great. It will give you the answer. You don't need to, though. After you leave class today, in a like very few short amount of time, you will know how to answer these questions without going to Desmos. We're going to use Desmos so that we can visualize why that happens. So by these two lines having different slopes and different y-intercepts, and actually I'm curious, does the y-intercept actually really matter? But we'll come back to that question. So different slopes tells us that at some point these lines will cross. We don't know if it's going to be close to the origin, thousands of x values away from the origin, but somewhere. Different slopes tell us that somewhere the lines will cross. Okay, so great. What we want to notate on our notes then, I got too many slides open, is, all right, different slope. This made one solution. This made one solution. Right, different slope, different y-intercept, we had one solution. Write down the next two. Y equals 9x minus 5. And y equals 9x plus 6. So the slope, different or same? No.
Same.
Slope is the same. Y-intercept is different. So when we look at what those lines are going to look like when they have the same slope as each other, what do we call lines that have the same slope? Parallel. And what do we know about parallel lines?
They have infinite solutions.
Either they never cross, like train tracks, or they always cross, like the new road that's paved on the old road, right? Like if you try to think of something on top of the other thing, like when you repave a road, you're putting the new thing exactly where the old thing was. You don't lay it at a weird angle, so you only cross in one point. So on our notes, what we should notate is same slope, different y-intercept, is no solutions. They never cross. But then, gosh, how long do I even have you guys? But wait.
Please remind me of that.
All right, write down these. I do still have a dilly bar in the freezer, though, if you want to go there.
Please.
Yeah, because I didn't eat it.
Can I please have it? I'm willing to eat dilly bar.
Yo, Mr. Watson, I have a trade for you, alright? A couple scraps of paper.
I got a $1. What if I froze?
Most grades after grading journals.
He doesn't care what. It's just more. That's the point. Reading boys.
See, there's no like best grade though, right? Because like if everybody masters or everybody gets a check. Now wait a minute. These aren't both. They're both in graphing form, but they're not in mx plus b form. Both of them. This one's mx plus b, but this is b plus mx. Still works. Are the slopes the same or different? Same. Are the y-intercepts same or different? And this will result in infinitely many solutions. Because it is legitimately the same graph on top of itself. Now, danger, like, I would normally ignore you guys just saying random things, but just so you're aware, at this point, it doesn't matter if stuff is a function or not. We're just trying to determine how many solutions. So you can actually look at a function and a non-function together as a system and figure out how many solutions they have. That gets really complicated. Because in that option, you might have 2 solutions. You might have 3 solutions. You might have 4. Like, it gets really awkward. So I get that you're joking about non-functions, but it gets really tricky when we pull in non-functions. So this is the gist of how do we look at these things and not go to Desmos to compare them. Now, the other thing I will caution you with is like when you have a situation like these two, or there's actually some other ones. I was looking through all of the options. Guys, when I go to look at your con work, I see every question you might be asked, and that's how I know what trapdoors exist. Right? I know every question you might get asked. Be careful with these. They're trying to lull you into thinking that there's a similar y-intercept when you actually do the division. They don't, right? This would actually become 3. So if we turn off, and just look at red and black, this, when we divide the whole thing out, is the same exact graph as saying y equals 2x plus 3. Right? So this is actually a y-intercept of 3 and a slope of 2. But again, different slopes, we know that they're going to have 1 intercept. So if we use that in our notes, and we come look at, I don't know why I find going backwards so difficult. We did not do this one. Look at it. Ask yourself, slope same or different? Y-intercept same or different? How many solutions would this have, everyone?
0.
None. Slopes are the same, so they're parallel, but y-intercepts are different, so they never touch. Check out this one. Don't fall in the trapdoor. Slope, same or different? Different. Even though they both show 4x at the start, I would need to divide the whole thing by 4. So we know 1 solution there. Guys, you can go back and make your life really easy. Does the y-intercept matter if the slope is different? No. So the only thing we care about is if the slope is different, it has 1 solution. It's when the slope is the same that we have to care about whether the y-intercept is different or the same.
But it's like if you look at the y-intercept, then it's the same as you already know.
Yep. Man, I can't believe we made it through all that. I was really not expecting that we would actually make it through all that. So the next stuff that you'll be encountering, sorry, if I have 2 minutes, I'm going to use 2 minutes. I did. I was hoping that you guys would see that when you were map testing, and some of you did. I assigned to the next batch of Khan Academy.
Yeah, I saw that.
All right, these are fun. Let's see if you can solve this with me just saying it, and then I'll put it on the screen. Kevin is 3... I really need to start tracking the amount of times that I start talking and then you start talking after me. It would surprise you how often you do it. At least I would hope it would surprise you. You were like, oh yeah, that's just me. That's a problem that you should identify. Kevin is 3 years older than Daniel. 2 years ago, Kevin was 4 times as old as Daniel. The hardest part of these problems is setting up what the heck is this saying. How do we mathematically write this out? Kevin is, first off, a really good security system installer. So if you ever need a security system, go to Kevin McAllister. But Kevin says, sorry, trying to make the Home Alone reference. Kevin is. Is equal, right? Like is means equal. 3 years older than Daniel. 3 years older than means 3 more than something, right? 3 more than what? 3 more than Daniel. But K and D are Kevin and Daniel's ages currently. I'm really glad we actually got a moment to chat about this one because I think this will stop a lot of you from making some mistakes. So when they say 2 years ago, what would Kevin's age be then? K minus 2. What would Daniel's age be back then? D minus 2. So when we... So Kevin's age 2 years ago was 4 times Daniel's age, but that is Daniel's age 2 years ago. So we do not use K and D. I mean, we do use K and D again, but we have to use K minus 2 and D minus 2. If we're saying K and D are their ages right now. Then we could solve this. And I'm out of time, so I got to get us to extensions. Okay, what are Kevin and...
Yeah. That's what I was thinking about.
Are you sure?
Yes, just one glance at it.
Yeah.
It's literally
He's 3 years older than
3 years older than Daniel 2 years ago.
And 1 times 4 is 4.
Okay.
4 times. So now they're only 3 years old.
Wait, can it be 7 and 4?
So should we submit?
That still doesn't make sense, though, does it?
No.
How could they be negative ages? So this is where we're going to pick up next class. I got wipes for you. I'm wondering if we made a mistake somewhere. All right, so wait. Alternative option, because we're just going to extensions, and if you don't really care about leaving super fast, I would keep you here, honestly. I would do math for the rest of the day. So, alternative option. What if we instead... Whoa, hold up. What if we instead think about K and D for the back then? If we think about Kevin and Daniel's ages 2 years ago as K and D. So then Kevin was 4 times as old as Daniel, right? Kevin is 4 times as old as Daniel. So now we would have K plus 2, right? Because the now, Kevin is 2 years older than now, is 3 years older than Daniel, so 3 years older than Daniel plus 2 years. Does this work out any better? Is where we're going to pick up on for you guys on Monday. So, all right, head to extensions. Sorry I kept you a little late. Yep, and I'm trying to steal this. Oh my gosh,
go
it's
finish
stuck.
the map test.
Oh, have fun.
I got to question 38.
Where should I put this? I don't want to.
Literally, actually, let me just look at it right now since we have time right now. Let me stop my recording first because this is all still going in my video.
I was gonna say, that Kevin McCall